Hi there, this is Renish here, and I'm going to give a brief introduction about CNC programming and CNC machining. So, I have split this video into two halves. So, in the first section, I'll be talking about CNC programming, and the second section would be CNC machining on a vertical machining center. So the way I've planned is that I will talk you through the CAD model and the engineering drawing in the first place, and I'll explain you how engineering drawing looks like and what are the different aspects that you need to cater so that you can strategize in your mind what are the different tools that you would be using. And then we're gonna import the CAD model onto the computer aided manufacturing software MasterCAM 2018, and we're gonna then decide and strategize what are the different tool paths and tools that we'll be using so that we can machine the components according to the engineering drawing specification. And I'll first explain you about the engineering drawing and then the MasterCAM 2018 software, and from there on we will generate the codes that the machine can read, and once the codes are generated, then we will transfer it onto the machine and we'll machine the part. So let's get started. So this is what an engineering drawing would look like. So you've got a different views of the part where you can see an isometric view, a left view, front view, and a top view. So it basically gives you a good idea how the part would look like from different angles. Um, so the isometric view would give you a good idea in a 3D view, and it has a lot of different dimensions specified in here by the engineer. So, and with some tolerance that you can see in here and other places in this engineering drawing. So, and this is the sheet information where you have information like what is the name of the part, what is the drawing number, what is the material, sorry. It says aluminium 6061. And If you closely look at on the front view, you can see that there's a pocket in the center, and it has a fillet in here. Then you've got a 3.5 millimeter hole, which is 10 millimeter deep. And then you can see this particular profile in here. So as a programmer, you need to decide what is the strategy that you're going to use, and what is the sequence of operation that you're going to go ahead with, so that you can carve out this part from a small billet. So, how I would look into this particular engineering drawing is that I would first go ahead with a profile milling, so that I can get this particular shape out, and then I will go ahead and machine this pocket, and lastly I would go ahead and drill this 3.5 millimeter hole. So in short, then we can get this isometric view. So I have a CAD model for this engineering drawing. What I'm going to do next is I'm going to import this CAD model. So basically a step file onto the MasterCAM platform, and I'll make you go through the steps and procedure how to generate a toolpath and subsequently getting the codes out of it. Okay, so let's get on to it. Alright guys, I've opened the MasterCAM 2018 software, and I have imported this CAD file onto the MasterCAM platform, and now my part is basically suspended in a way that my Z, Y, and X axis is basically at the center. So I need to make sure that my work coordinate system, my tool plane system, and my construction plane system are on the same view. And that view basically decides the view for the CNC machine as well. So as a CNC programmer, you need to first think if you gonna what kind of Z reference you would like to give, whether you would like to give a bottom Z reference or a top Z reference. So I'm going to show you first how you create that environment where you decide and give input onto the MasterCAM software which Z reference you would like to give, whether you would like to give Z top or Z bottom. So how I usually do this is what I do is I go onto the transform tab and then I select on the translate. So once I do that, I get an information saying that select the entity to translate. So I drag this using my mouse and then I click on end selection. So and then I right click and then I click on the front view. So I then click on the move button. So it's what it's going to do is basically it's going to move the part where I want to, and this is where you can make these changes. So I'm going to click on, I'm going to basically move on to so I have to go minus 11.5 and just see here. So that's where the Z references would be. So I'm giving a Z top reference. So when I'm giving the tool offsets on the CNC machine, so I'm going to take the tool offsets from the top of the part. So that is something that you need to really think about before you start machining, and what is the best optimum way for you to do, either use a top Z reference or a bottom Z reference. So I click on this OK button and then I see then I click on fit, I click on zoom 80 and then I'm going to clear the colors. So it still hasn't moved there, so I'm just gonna go ahead and then click on the translate button again. So I'm going to drag this once more and let's click on this. Yep, so basically it's asking 3.5 and I click on OK. I'm just gonna double check if everything is alright. So yes, and now I can see that my part is correctly placed on the work coordinate system. So I've got a, so when I see the top view I can see the y-axis this way, x-axis on this way, and the z-axis which is on the top. So this is how you need to place the part onto the CNC machine's bed. So you can use a vise, or maybe you can just clamp it down onto the bed. But the best way to do is especially when you're doing just one product, machining one component, is you use a vise and then you just clamp it on top of it and start machining. So now that the work coordinate system, tool planes, and construction plane is basically the same, which is the top views. So we can go ahead and get into the next step. So I'm going to click on top view, and then the next thing that I'm going to do is I'm going to create a level. So I'm going to say wireframe. So wireframes are important basically for your selection of your chains on which the tool path runs. So the wireframes or the chaining is basically a skeleton, and the tool path follows that skeleton. So that's the reason I created a new level. So I'm basically in this level 2, so I can make any changes from here on. So what I'm going to do next is I'm going to go home, sorry, wireframe. I'm going to go on wireframe. I'm going to click on curve all edges. So what it's going to do is it's going to take all the points and which can be easily read while I'm doing the chaining. So Now you can see these blue lines that you can see, and basically what it does is it creates a skeleton on the part. So I'm going to click OK. So if I go on to the wireframe mode, so I can see the whole part in a wireframe view, and becomes really easy to machine the component, and while doing the chaining it easily picks up the points and the entity. So now, that being done, we can get into the next procedure, and the next thing that we can do is go on to the machine and click on mill. So we're going to use the vertical machining center to machine this part. So I'm going to click on this mill, and I'm going to click on the default button. So once I click that, I have a new mill tool part that I can see. So you can see there's different kind of tool parts. So you can see two-dimensional tool parts, 3D tool parts, and multi-axis tool parts. So this being a two-dimensional part, so we're going to just stick around with the tool parts that are provided over here, and that would basically do our job. This is the environment where you can see a lot of different views. So you can see the toolpath here, you can see the machine group, and you can see the properties, the tool settings, the stock setup, and then this is the toolpath group 1. So I'm gonna go through each of these information in here and explain you a bit more about it. So to start off, I'll just click on the tool settings, and then I'm gonna go for feed calculation. I'm gonna click on from the material, so it gives you more good information about the feeds and speeds based on the information that is already there on the MasterCAM library. So I'm going to also click on assign tool number sequentially, one duplicate tool numbers. Yep, and this. So next, what we're going to do is we're going to select the material that's going to be. So in the engineering drawing, if you can see here, you can see that the material that is being used is aluminium 6061 T6. So we're going to just find that in here and see if we can click. Yeah, there you go. So aluminium 6061. So I'm going to click on OK and click OK. So now the software knows that I'm basically machining 6061 aluminium. Excuse me. Yeah, so I'm gonna hover on to the next tab here. It's called the stock setup, and basically it's asking me information about how you're gonna how your stock would look like. So there are a couple of different ways of basically setting up your stock. So what I'm gonna do is I'm gonna just click on the bounding box, and I'm gonna drag the whole part in like this, and then I'm going to click on the end selection. So you can see how the software has picked up all the points. So but ideally my stock would not look like this, so I'm going to give some extra based on what the the material that I have is 65 millimeter on the x-axis, and on the y it's about 50, and I'm gonna put that. So, and on the z it's about 25. 25. You can see how it goes. Okay, so it's basically taking information from the bottom. So I'm going to click on this, and again click 25. Let's see how it happens. Let's click on OK. And so basically this is what we don't want, because when you look onto the front view, you can see the Z preferences in here, and your stock is about 2mm above them. So you need to basically fix this. So a couple of ways of doing this, and one way is just click on this and kind of get it right. Yep. So I've got the stock and the stock being set up and the part inside of it. So this basically helps you when you're simulating your tool path, so you can basically see how the stock that you have is being machined properly, and gives you a really good idea and visualization before you start machining. Okay, so that being done, so we've clicked on and inputted some information in the tool settings, and then on the stock setup as well. So everything is good to go, and we can start machining. So what I have strategized is I'm going to first machine the outside profile. So you can see this profile in here. So I'm going to machine this profile first, and then I'm going to go and machine the pocket inside, and then finally I'm going to go ahead with drilling this 3.5mm to 10mm depth. So before that, I need to decide what are the tools that I'm going to use, and also the tool path that I'm going to use. So with this particular profile, I'm going to go with the contour profile milling, but I need to know what is the kind of tool that I need to use. So a really good way of understanding that information is just go onto the home tab, and then you click on the analyze entity. So you basically get information about the radius. It says 7 diameter. So if I have a 10mm tool, so I can easily machine this profile, and I can also use the same, so I can use the 10mm end mill to rough machine with leaving some stock on the sides, and later then I can go ahead and give a finish pass where I can get the desired result. So let's get on to it. So I'm going to click on toolpath, and then I'm going to click, so I'm going to click on the contour button over here. So it's asking, so this is where chaining comes in, and this is where your toolpath will look like based on the chaining that you select. So there are a couple of information in here. You can use the construction plane, you can use in the 3D format, so you can, like, this is the wireframe and this is the solid format. So there's a lot of options in here. So I'm just going to stick on to the construction plane, and we'll click on this wee thing, and then you can see that the software has picked up the whole profile, and then I'm just going to click on OK button. So now that being done, so you get a dialog box that opens up like this, and there's a lot of information in here, and this is where the engineering as well as the practicality goes in. So inputting these information is primarily based on your experience, and the machine that you have, how fast is your machine, and there's a lot of engineering factors that you need to consider. So I'm going to quickly go through all these information so that you just get a bit of an idea how it's being done. So the tool path type, I've clicked on the contour, so I move on to tool section. There I need to define what tool I would be using, so I'll be clicking on filter button, and I would say I need a 10mm diameter flat end mill. So here you go. So I'm going to click on OK, and I'm going to click on select library tool. So because I filtered it down, shows me a flat end mill, 10 millimeter diameter, 4 flute, 16 millimeter flute length. So that's okay. So I'm just going to click on this and see the tool number is tool number 1, and you've got your length offsets and diameter offsets as 1. So now you're going to decide what is the feed rate that you're going to use. So because we're doing this for the first time, I'm gonna machine at a very slow feed rate so that I get the part right. So I'm gonna go with a feed rate of 1200, and yeah, this is 4500. So basically, feeds and speeds is something that you can there's a mathematical calculation for it, but as you start getting more knowledge and you start machining more components, you get an idea what the speeds and feeds that you can ideally start off with, and then as you move on to production you can change it to save more time and reduce the cycle time. So I'm gonna go ahead with the plunge rate of 800. So I'm gonna make a comment here so that the operator can know that what is the tool that I'm using, and I can also provide some other information that would be helpful for him. So what I'm going to type in here is I'm going to say op1, sorry, I'm going to use cap lock, op1 dia 10 in mil roughing, and I'm going to leave 0.2 millimeter stock. Okay, so that's pretty much the operator can basically understand. He'll be able to understand, okay, so this is what is going on with this particular toolpath. So I'm going to click on holder. So usually you keep it default unless you have some specific holders out there. So there are a lot of holders out there, BT40, CAT 30. So in here we use BT40. So for that, default holder is more than enough to get rid of the needs. Okay, so moving on to the next parameter. So it's asking for what type of compensation type that I really need to have, and I'm saying, okay, there are different kind of compensation type where you have computer deciding left to right, or you use the control or veer where you can make the changes based on you giving a diameter offset onto the machine, and the machine will pick it, or else you can just switch off the compensation type. So you can also decide what direction you would be using, a right or a left. So if you're using a left one, it's a climb milling, or if you use a right, it's a conventional way. And also it also talks about what are the kind of contour types you would like to use. So there's 2D, two-dimensional, ramp, and this remachining and oscillate. So I usually prefer ramp because it saves a lot of time, and it's a really cool toolpath. So I clicked on this and it's asking me the stock to leave on wall. So I've already decided that I'll be using 0.2 millimeter and with a ramp depth. So I'm gonna start off with a small number. So I'm gonna just go with 0.4 millimeter depth of cut on each pass. So I'm gonna click on this 0.4 and see and move on to the next tab. So it's asking me because I'm not using the 2D and contour type, I really don't have to activate this, or I think you can't even activate it in here. So it's also asking lead in and lead out. So I'll just keep this as it is, and once I generate the toolpath, I'll see what modifications we can go ahead with. Breakthrough, multipasses, not required, tabs, linking parameters. So this is what is the most important part of how your toolpaths would look like. So there's clearance, there's retract, there's feed plane, there's top of stock, and there's depth. So by this particular diagram, you can easily understand what the clearance and retracts is. So the clearance and retracts are basically rapid moves, and the blue lines are basically the feed, and that's where the machining happens. So you just need to be really careful, and I use 100 millimeter as the clearance, and I use clearance only at the start and in the end of the operation, and I keep the clearance absolute, and with the retract I just want to keep it a little bit safe, so I just give 25 millimeter and I just click on absolute. With the feed plane as well, so where the machining starts, is I give 10 millimeter, and I usually use an incremental value for that. It's much better, it saves time. And now it's asking me for the top of stock, so having this in absolute value, so I'm going to click on the top of stock. So it's asking me where is the top of this particular profile stock is, so I'm going to click on this, so it knows that it's 0. That's the reason I've given Z as the top reference. And it's asking me what is the depth that you would like to use. I'm still gonna use absolute command on it. So I'm gonna go click on here, and I'm gonna click the depth. So it automatically picks up. And if you go and have a look at the drawing in here, so you can see the left view. So you can see 15 millimeter. So that's exactly what it picked. Okay, so moving on to the next home position. You don't have to do anything in it, so it's all good. Coolant, it's already on. All right, so I've fed in all the parameters and information, and I can basically, before clicking on to the OK button, I can visualize, or I can see what my toolpath would look like, so I can have a preview of it. So now I see there's a bit of a problem. So I see there's toolpath is inside, so I'm gonna have a look, and I'm gonna change it to left. So I'm gonna go with climb milling. That's what CNC machines are good for. So once I'm gonna click on the preview toolpath, it basically gives me the toolpath that I really wanted to. So now you can see that just open the analyze toolpath button, so you can see that this is the position where the 10 millimeter tool is gonna come and start machining. And this is the this is the retract. Also, there's no retract, so it's going from here. This yellow line is basically the rapid move. So from Z100 to Z10 is where that's where I've defined that the feed plane is going to be 10 millimeter. So from here, your basically feed starts. And then it starts machining, and then once it does the whole toolpath, at the end it retracts, and straight away goes up to 100 millimeter. Okay, so one more problem is that it's, now you can see these red lines, which is the stock setup. So that's my stock, and so the tool is directly going and plunging into it. And what it will do is it will leave some material in here which I really don't want. So what I'm going to do is I'm going to make some modification in my toolpath. So I'm going to go on to the parameter, and then I'm going to click on multipass, and then click on this multipasses, and it's asking me for number of rough cuts, so I'm gonna go with 2 and give 5 as a spacing, and I'm gonna see how it look like. Let's say if I get 10 millimeter and see how it goes. All right, I think that would do. That would do good. So I'm just gonna go on to. I'm in wireframe mode. I'm gonna go on to the solid form. So I'm gonna see. I can basically verify, and this is what the simulation tool is all about, and see how it's gonna behave when I activated the multipass. So I'm gonna click on the play button, and yep. This also gives you the total time this particular operation would be for, so it says 13 minutes. Okay, still say that there's still need to make some modifications so that I can get these little lines out. Okay, so I'm gonna go back, I'm gonna make some more modifications to see if 12 would fit in, or maybe 8 would be a much better option. So I'm gonna verify this toolpath. Let's see if it can do the job that I want it to do. I think it's much better. I can increase the speed of the simulation. Okay, so this is what I want. So if I just go on to the top view and just see, zoom in, and I can see this is the 0.2 millimeter of stock that I left for my finishing pass. So I'm finished with my roughing operation, and I'm going to go and do the finishing operation as well. So doing the finishing operation is really simple. Basically, we just need to copy this and just paste it again and make some modification in this particular toolpath. So you're gonna go ahead and you're gonna click on tool. You can maybe lower the feed rate so that you get a really nice finish, and maybe increase the, you're gonna say up to finishing. You can give maybe, yeah, you can just take this out. Finishing up. Okay, so you don't need to touch on the holder. You can go back. You can go to cut parameter, and now this is where what is important. So you were machining with the depth of cut of 0.4 millimeters, so you can basically increase it. Let's say you can give about 0.8 and go with 0.0. And lead in, lead out, it's all good. Multi-pass, we don't need it anymore. And these parameters would be the same, so I'm just gonna, so now because I made a few modification onto this particular toolpath, now you can see a red line, red cross mark, which means that the operation is dirty now, so you need to regenerate the selected operation. So you're just going to click on this, and then the red cross is gonna fade away. So I'm gonna click on this, and I'm gonna just click on toggle display on selected operation. So it's once I click it off, I can only see the second operation's toolpath. So now I can see how the second output look like, and see the lines, and it's taking a 0.8 cut, and I can see in the back plot how it's going to machine. So okay, so all good. If you really want, you can have a look in a simulation as well. Really quick. Now you can see these lines are much better. So it basically did the job. Yeah. Okay. So the whole operation till now takes about 17 minutes. Alright, so I'm going to click on the toggle display on selected operation, and then I'm going to click it again so that I can get a good view of the part. So the next operation that we're going to do is machine the pocket. So before machining the pocket, I need to understand what kind of tool that would be the most appropriate to machine this pocket. So a good way to do this is you can get to know by getting to know what's the radii of the fillet. So you see that the diameter is about 6 millimeter, and with radius of 3 millimeters. So a 6 millimeter end mill would do the work, or you can go with a 4 end mill, and you can still get the result. So I think I'll go with the 4 end mill and machine this pocket. Alright, so to do this, I'm going to use the same toolpath that I was using before. So I'm going to use contour. No, I'm going to go with a pocket milling. So it's asking me what's the chaining would look like. So I'm going to click on this, so it's not able to pick up the points properly. So the best thing would be using this, and yeah, work. So once your chaining geometry has been defined, you can move on to. So earlier I was using a contour toolpath, and for this particular pocket, I'm going ahead with the pocket toolpath, and it has a completely different feature. But what it does is basically scoop out the material and gives you the desired shape that you want. Okay, so I'm going to go ahead and select the tool for this. So we've decided that we'll go with a 4 end mill, so it's already 4 written here. And then I'm going to click OK. So there you go. You have the 4 end mill, and you can see it's a 4 flute, 7 millimeter flute length. Really doesn't really matter. You just need these information in here, as in the 4 end mill. So it would be the second tool number, and then I'm gonna just make some modification on the feed rate. So I'm gonna go a bit slow, 1200, and somewhere around 5000 RPM. The plunge rate is really high, so I'm going to go with 800. It's safe. Then, so this becomes your third operation. So you put op 3, dia 4 end mill, roughing we'll give 0.2 millimeter, or we'll give 0.1 millimeter as the stock for this third operation. So there you go. So machinists can see what would this particular tool path will entail. Okay, moving on, we're going to click on the cut parameters. So we're going to go with the climb milling and standard pocket machining. It's asking me what is the stock to leave on the wall, so I'm going to go with 0.1, and with the floor I'm just going to go with 0. And it's asking me for what is the kind of tool path you basically would like to opt for. So let's see what would be the best to get a really good finish. So I'm just going to click on this parallel spiral in the beginning, and then see how it would look like in simulation. It's asking me for the entry motion, and I'm going to go with helix entry. So just I'm going to click off. I'm just going to switch off the finishing pass. Just don't need that at the moment. Depth cuts. I'm going to click on the depth cuts. We're going to click on the depth cuts because it's not a ramp toolpath. So with a 4 end mill, the best thing that you can go ahead with is a 0.3 or 0.2 when you're machining it for the first time. Based on how good is your tool, you can increase the depth of cuts. So to be on the safer side, I'm going with, maybe we can go with 0.3. Doesn't matter. Yeah. Okay. So moving on, it's asking me for some other information in here and linking parameters. So I'm gonna go and click 100 millimeter with absolute, and then I'm gonna click on use clearance only at the start and the end of the operation. That becomes really easy and saves you a lot of time. The retract absolute command. Yep, so it's all good. It's asking me for the top of stock is the same. I'm going to click on absolute command for this. It's asking me for the depth, so it's pretty easy in here. You just go here, hover, and then click on this line entity, and then you will get to know, okay, it's 10 millimeter deep. Okay, so you can see the tool path is generated, and this is how it looks like. I'm just gonna click on this backplot, and I'm gonna see how much time it's gonna take. Say 7 minutes. It's alright. Yeah. Okay, so that being done, I can basically just see how it's going to look in the simulation. Okay. All right. So I still have about 0.1 stock in here, which I can machine it using a different toolpath. I will just go with the contour toolpath and get that 0.1 stock removed as a finishing pass for this particular operation. This is another operation that we're gonna use. All right. So I'm going to click on the contour milling toolpath. It's asking me, I'm going to go on the construction and asking me to select the chain. So I'm going to click on this. Oops, sorry. I'm going to click on, let's see if I can just get the else, I'm just gonna maybe, yes. So all you need is the chaining geometry to be done perfectly, and you can get it. So maybe in here some lines are not complete, and that's the reason it's not showing a green line. Okay, so I'm gonna click on OK button, and then the next thing I'm gonna do is I'm gonna use the 4N mill, and I'm gonna give 800 as a feed, 5,000 is 5,500 feed rate, sorry, speed, 800 as a plunge, right, and it becomes op 4 dia 4N mill finish pass. Yeah. Alright, so I'm gonna use the compensation type as the computer. Go ahead with ramp. Well, so and 0.5 would be good. Yeah, so there's nothing. 0 is the stock to leave on the walls, and same goes on the floor. Okay, I'm gonna click on linking parameter. So clearance of 100, retract of 25, feed plane, incremental, it's all good. All 10. Alright. So we basically got our toolpath in here. So let's see, how does all the toolpath look like when you verify it. Good. So I'm gonna remove the tool. Yep. That's what I wanted. Alright. So pretty much done with the outside profile milling and inside pocket. The one that we are left with is this 3.5 millimeter hole. Excuse me. So this is our last operation, and what I'm gonna do is I'm gonna